So this will be the quadratics homework, which will probably be assigned Thursday or Friday. I like doing things ahead. I'm going to do number 1 just because I'll do it differently than a lot of you will do it. Something you may not realize you can do. You could put it into y equals mx plus b form. Could do y equals mx plus b. And I'll go ahead and do it just so you can see it. That'd be y equals negative 3x plus 6 plus 3, which is y equals negative 3x plus 9. You can do that. It doesn't take long. It's easy. Or you could also use transformations. The mother function is y equals x. It is a line. I know that because that x power and x minus 2 is to the first power. And I can just follow the rules of transformations. I can go not left, right 2, and up 3. I can use that as my initial point. I don't have to actually know what the y-intercept is. From here, my slope is to fall 3 and run 1. And I wonder if I've got enough room for tick marks here. 1, 2, 3, 1, 2, 3. Instead of falling 3 and running 1, which I could do, I could also go the other way. I could rise 3 and run left 1. And that would actually put me right up there at my y-intercept. It's just something you can do if you understand transformations. So there's that. It's a line, domain and range, or negative infinity to positive infinity. Or if you like set builder, all values of x, all values of y, such that either x or y are elements of the real. You need to understand both. Let's see here. I don't want to do all of these. The hardest of the quadratics is probably 4. The mother function is y equals x to the second. It's going to look like the parabola. And the transformations we have, which I need to talk about that over here, back to this. It was right 2, and then up 3, if you did it my way. Actually, it ends up just being up 9. Vertical, shift, up 9. And we have a scale factor, we have a vertical stretch with a factor of 3. And what else do we also have on that one? We have a reflection on the x-axis, reflection over the x-axis because the slope is negative. Now, speaking of reflections, I'm actually transformations. I'm going to do that here first. This is actually not left 2. This is right 2. Things in parentheses lie about signs. So we have a horizontal shift. What did I say? Right 2. And then we have this one, which is up 4. We have a vertical shift. Up 4. We have a scale factor of 3. That's a vertical stretch. With a factor equal to 3. And the last thing we have is we have that reflection over the x-axis. We also call that a vertical reflection. A vertical reflection, also known as x-axis reflection. That bothers some people. They're like, but why is vertical? You're flipping vertically. The domain of a quadratic is going to be the same, negative infinity to positive infinity, or all values of x such that x is an element of the real. It's the range that you have to understand the graphs. I can look at this one and tell you its range, but for y'all, you need to graph it. It should be negative infinity to 4. Anyways, this thing goes right 2, and she goes up 4. And this can also be thought of as initial slope. So I'm going to fall 3 and run 1. That put me right there. And because it's a parabola, In this case, it opens down. I have to have 3 points plotted. And there is a rough graph of my parabola using the concept of transformations. It's not hard to do. Now, the low value this thing achieves, and by the way, when you do interval notation, you start with the small value and you move to the high value. The low y value this thing achieves is way down at negative infinity. And it rises all the way up to 4, and 4 is a point you can actually be. We bracket it. It's a solid dot. And that's 4, which is probably the hardest one on here. I need to save a couple of those for you. I don't want to do anything else on the front page. That's weird. 7 is kind of a rough one with transformations because you're not transforming from the mother function, you're transforming from this. So there are things that have happened. Quite a few things have happened. We've gone from positive 3 to negative 2. Well, this would have been, left 3, and this is saying right 2, opposite of signs. So we've actually horizontally shifted right 5 units. Oh, no. This became that. We've horizontally shifted left 5 units because we went from being on the right 2 units to the left 3. So horizontal shift left 5 units. We talk about our vertical shift. We were at 4 units high. Now we're 5 units below. There's a vertical shift down. 9 units? We have reflected over the x-axis. This negative sign got introduced. So there is a vertical reflection. And there's one more. That negative symbol got introduced right here. And this is the location of the horizontal. And it changed from negative to positive inside. So there was also a horizontal reflection. The original thing would have opened up and then been on the other side of the y-axis. The new one now opens down and got moved over to the other side of the y-axis. Look at 9. The mother function y equals x squared is transformed such that it is vertically stretched with a factor of 3. So if I look at that first bit here, I get y equals 3x squared. Then she is horizontally stretched with a factor of 2. That becomes y equals 3 parentheses 2x all squared. Interesting how that works. And, I screwed up there. Reciprocals. Those are always reciprocals. Entries a half. Shifted right 3. Now this is going to be a little bit harder to do because that half is there. In order to shift right 3, I would normally think x minus 3. But because of the half, I have to think 1/2 x minus 6, because half of 6 is 3. So it's a little tougher. That's why I'm doing this one. So that handles the shifting right of 3. I got that 3 out there. Milbrath messed that one up. 3/2. No, ignore me. Because the way I'm writing this, it won't matter. I am seriously overthinking things. That'll do it, because it's already in factored form, so that'll do it. And then the last thing is to go up 4. Horizontal stretches have always been something that has bothered me. I tend to overthink them. But since I'm using this form, I don't have to think. I just have to trust the form. So that will do it. All right, that's that. Next thing in here is going to be some ACT stuff. I'm going to pause it, take myself a quick break. Now I'll be right back after these messages. And I'm back. All right, the set of all positive integers that are divisible by both 15 and 35 is infinite, because there are an infinite number of things that can be divisible by those two terms. What is the least positive integer? So what I'm doing is I'm looking for the smallest number divisible by 15 and 35. Least common, I don't even remember what the terminology is. It's so long ago. Well, 15 doesn't enter 5. 15 does not enter 50. Does 15 enter 105? You know, maybe I go old school. Maybe I do this in my head. How many times is that going to happen? 7 times? Yeah. So it passes that. 105 and 35 should happen 3 times. So there she is, 105. They both go into 210 too, but this is about the smallest positive integer. 25 is geometry. We are told that A to B is congruent to A to C. And you had a theorem in geometry. It said if two sides of a triangle are congruent, that's the terminology for congruent, then the angles opposite congruent sides are also congruent. So that means that this missing angle here, I don't know about it. These two angles are the same. You also know that the sum of angles in a triangle equals 180 degrees. So I'm going to take these two unknowns, a question mark plus a question mark, plus 58 degrees is 180. And I have two question marks, which I'll call 2x. 180 minus 58 is what, 122? Seems right. And x would be 61 degrees by that logic. And that's an answer choice. 26, about 1.48 times 10 to the 8th square kilometers of Earth's surface is land. The rest is about 3.63 times 10 to the 8th square kilometers. I like that these match. So I'm just going to do 1.48 plus 3.63. And that would give me 5.11, I think. 3, 7, 11 left over. Times 10 to the 8th square kilometers. That is the surface of Earth. Now, why did I do that? If a returning space capsule lands at a random point on Earth's surface, which of the following is the best estimate of the probability that the space capsule will land in water? So, water is the 3.63. And the total is 5.11. All I got to do is simplify that number. That's it. And I'm just going to go old school. Should I? Or should I just be lazy? It's 3/5, isn't it? It's either going to be G or H. So let's just see what that reduces down to. I've got that 3.63. You won't be able to use your phone on the ACT, but I don't feel like going and grabbing a TI-84. Sitting pretty over 5.11. 71%, it was G. That's basic probability. Of course, a lot of kids would never come up with that 5.11 number. You wouldn't. thing to add those two together, but you needed the total surface of the Earth, not just bits and pieces of it. The solid rectangular prism below was built by alternating congruent black cubes and white cubes such that two cubes of the same color have at most one edge touching. What is the total number of white cubes that were used to build the prism? Ugh, that could be bad. But it looks to me like there's a pretty good pattern here. Let's see, let's figure out the total cubes. We got 3, 7. There's 7 cubes here. 5 there. And what's our height here? 6. Total cubes is 7 times 6 times 5, which is 210. Presumably it's half that, but I don't know. I really don't know. That's my guess. Now it looks to us, so this alternates. We got 3, 4, 3, 4, 3, 4. So on average, and I think that pattern holds, 3, 4, 3, 4, 3, 3, 2, 3, 2, 3, 2. We're going to find the average number of white cubes. We got a 3 and a 4 makes 7, 10, 14, 21. And what I'm doing is I'm adding the white cubes here. And this may not be my very good logic here. Let me pause this and think about it for a second, because I don't want to go down and waste your time on this one. This one's kind of tricky. So I was taking a look at that one to see if I was right or not. I established by counting that there were 21 white cubes on this face right here. And then I was looking at the pattern here. It looks to me like when you go to this next series of cubes right here where my pen is, that they alternate colors. So there's 21 on each on that particular section too. So what we have here is we have 5 sections with 21. So my initial guess was right. There's 5 basically panels of 21s. And it's 105. 5 21s is 105. I just wanted to make sure it was right. Let's see, one side of square ABCD has a length of 12 meters. A certain rectangle whose area is equal to the area of ABCD has a width of 8 centimeters. What is the length in meters of the rectangle? So they gave us a square. That's the big thing. It's a square. It says it has sides of 12. And squares have congruent sides. So if one side's 12, they're all 12. Area would be to take a side and square it, so it would be 12 times 12, which is 144. And then they start talking about this rectangle, and they tell you it has a width of 8, and now you know it has an area of 144. What's the length? Well, area of a rectangle is length times width. The area is 144. The length is unknown, but the width is 8. Divide out the 8. And how many times does 8 go into 144? 16. There you go. No, not 16. 18. 18. 30. The average of a list of 4 numbers is 92. A new list of 4 numbers has the same first 3 numbers as the original list, but the 4th number in the original list is 40. And the 4th number in the new list is 48. What is the average of this new list of numbers? So I'm going to talk about the original list. The average of a list of 4 numbers is 92. So I take 3 things that I don't know, and I add in the 40, and I divide it by 4, and I get 92. That's the equation for the original list. It says a new list of 4 numbers has the same first 3 numbers as the original, but the 4th number is 40. Sorry, but the 4th number in the new list is 48. And I don't know the average. So I'm going to use this original equation to figure out what these first three numbers are, at least the average of the first three numbers, because I'll do the job. So I'm going to 4 both sides to counteract that division. 4 times 92 is what? 368. And there are 3 x's. So 3x plus 40 is 368. Take away my 40. 3x is 328. Make sure I didn't make any mistakes. Doesn't look like I did. The reason I question myself there is because I got a decimal, and when I was a kid, the ACT did not like decimals. Pretty good. I got 109.3333. That's what my x value is. Interesting. So now I know these three guys, and there happens to be 3 of them, but you take your 109 and a third and you multiply it by 3. If you sum up those first 3, you get 328. The fourth number is now 48. All of that over 4 is equal to the average. And I got 94. I guarantee you 2 out of 3 kids miss a question like that, and it's probably higher than that because they don't understand averages. It is what it is.